In all of their claims to scientific proof, evolutionists have stumbled onto proof that the universe is young in the form of wave-particle duality. According to physics, all particles can also be described as waves and vice versa. The catch to this is that it only becomes a particle or wave once it's been observed. Until then, it doesn't exist. This is how starlight from billions of years away reaches us in less than 6,000 years. As light is emitted, it travels instantaneously until it's reflected, collapses to a wave, and then begins traveling at a fixed speed. This explains why we can only measure the speed of light by reflecting it. When scientists mention the speed of light, they should really be calling it the round-trip speed of light, as the one-way speed of light is instantaneous. Another example of this, when an electron changes from one orbital shell to another, it happens instantaneously. Only after we observe it can it be said to have a particular location or speed. In fact, not only does this show that creationism is scientifically possible, it also implies the existence of a God. Without a grand observer, none of our universe could exist. The very fact that we are here comes down to the fact that God saw his creation and that it was good. How have these conclusions evaded scientists for so long? I had to investigate. Quantum mechanics is weird. I mean, really, really weird. If you think you understand quantum mechanics, you don't understand quantum mechanics. This quote is often attributed to Richard Feynman. Whether or not he actually said it, the statement echoes a much earlier quote from Niels Bohr. If you can fathom quantum mechanics without getting dizzy, you don't get it. The problem with quantum mechanics lies in a phenomenon called the observer effect. This concept states that observing anything in nature affects it on some level. While naturalists observe lions, they are interacting with the lion's ecosystem, thereby affecting the lions. When you observe a football game, you are interacting with other members of the crowd, which cumulatively affects the players on the field. Even the simple act of checking tire pressure requires allowing a small amount of air to escape the tire. In all these cases, steps are taken to reduce the effect of the observer on the subject. In quantum mechanics, however, such precautions are nigh impossible since our senses can't help us at the atomic level. The only way to gain any knowledge of nature at the atomic level, then, is to force collisions of subatomic particles and note their interactions. Until these interactions take place, it is impossible to know anything about the subject. For this reason, the subject can be said to exist in all states, including as a wave or as a particle, until it is observed. At this point, the possibilities are said to have collapsed into the state they are observed in. A photon of light, for example, can be described as a particle in that we can expect it to travel in a straight line through a slit, projecting an image of that slit on a wall behind it. When a second slit opens up, however, instead of seeing two slits on the wall, we see a pattern of slits. This is because as the photon is traveling through the two slits, it is no longer acting like a particle, but as a wave. When a wave passes through one slit, it creates a pattern of waves. When it meets the other wave, both of them interact. At some points, the crests meet and amplify each other. At other points, the waves cancel each other out, leaving these interference patterns. Until the photon passes through one or more slits, we can't say for certain whether or not it is traveling as a wave, a particle, neither, or a combination of both. It would also seem natural to assume that an observer would be a conscious entity, like a scientist. But in fact, the observer is simply the matter interacting. The experiment continues to yield results even after scientists leave the room. So the observation is the interaction. With no interaction, there is nothing to measure. So as far as we are concerned, the subject does not exist until we measure it. This is what's led to a lot of confusion, allowing for pseudoscience to abuse this concept. Deepak Chopra, for example, has misrepresented it to mean that reality is an illusion until our conscious minds create it. But this necessarily violates the first law of thermodynamics, as it is energy being created. Some creationists, however, have built on this misrepresentation in a far more creative way. In 2015, a paper by Andrew Truscott of the Australian National University appeared in the journal Nature Physics. In the paper, Truscott chronicled an experiment he conducted with helium atoms. After supercooling and isolating individual helium atoms, he fired them individually into two intersecting lasers pointing at separate detectors. When the detectors were viewed, they showed that the atom had chosen a specific laser and landed on one detector each time. When the beams from the laser were recombined, instead of the atom choosing a path like a particle, it created a wave interference pattern. What this experiment showed was that, like photons, atoms also have wave-like properties in that they make the decision to act like a wave or particle before they encounter any means of splitting them or recombining them. This has been argued by some creationists to mean that the atom doesn't exist until it is detected. But that leaves the question, what was fired into the intersecting lasers to begin with? This model was expanded by some creationists to apply toward the speed of an electron changing its orbital. When it gains energy, it moves to a higher orbital shell. When it loses energy, it releases a photon of light and moves to a lower orbital shell. As far as we can detect, this change in orbital is instantaneous. This is, unfortunately, where the creationist argument stops. There is actually a moment of uncertainty for the electron where it is impossible to tell where it actually is. This moment is equal to the amount of time required for light to travel from one electron shell to the other. Ignoring this, the creationist argument then goes on to say that light travels instantaneously from its release until it interacts with other matter and then continues at the established speed of light. Knowing that quantum mechanics is often counterintuitive, this argument might seem to make sense to some, but it is demonstrably false. On February 23, 1987, a supernova appeared in the sky that was visible to the naked eye. It was discovered independently by Ian Shelton and Oscar Duhalde at the Campanas Observatory in Chile and Albert Jones in New Zealand. Labeled SN1987A, it shone brightly for several months before eventually fading. It was later discovered that the star which had gone supernova had been Sandelik-69°202, a blue supergiant 168,000 light-years from the Earth. After its explosion, a ring of gas and plasma was visible surrounding the supernova remnant. Although no neutron star has yet been confirmed, the center of the supernova remnant is very dense with regular patterns of increasing and decreasing brightness. This ring around SN1987A is roughly 2/3 of a light year from the star. Because of this, the light from the remnant takes about 8 months to travel to the rings. We can witness this directly. When the remnant brightens, 8 months later, the rings brighten. When the remnant dims, 8 months later, the rings dim. The light from the center of the supernova remnant is traveling directly to us, while the light from the rings is reflected light. If the supernova occurred in 1987 and the light traveled instantaneously, then in the creationist model, we should not even be able to see the light from the rings for another 168,000 years. So in the end, there is no such thing as a one-way speed of light, and nature exists whether you observe it or not. Wave-particle duality, another example of how creationism taught me real science. If there's a creationist argument you think I should investigate, please comment below. It may become the basis for a future episode. In the meantime, subscribe and make sure you don't miss it.